Data sharing policies form a basic policy set for data management applications. We have looked at policies described in the Policy Examples Workbook for multiple data management applications. They included data sharing, digital libraries, data centers, federation, protected data, and NSF data management plans. The basic policy set used by every data management application is the data sharing policy set. This policy set controls the data grid middleware, including controls for moving data, executing files, managing quotas, and defining how users are added and deleted. There is overlap between the data sharing policy set with other data management applications, although each application does enforce unique tasks. The overlapping policies represent a minimal set of policies that should be enforced by every data management application. What is the minimal policy set? A goal of the Policy Examples Workbook was to identify the basic set of persistent state information and set of operations needed by most data management applications. The basic policies manage the following tasks within the data grid. These include examples of policies for managing interactions with technology, users, and the collections. For interacting with technology, you needed to manage data grid renaming, number of I/O streams, file registration, physical file naming, number of execution threads, and storage resource selection. For managing interactions with users, we had to manage user creation, user deletion, and storage quotas. For managing collections, we had to manage bulk data processing and a metadata catalog. Several of these policies manage interactions between the data grid and external technologies. The choice of parameters for each policy depends upon the hardware and software systems accessed by the middleware. Thus, a server that has a larger number of cores can support a larger number of execution threads. A storage system that can handle a very large number of files in a single directory will not need to implement naming and direction. With iRODS 4.2, it will be possible to add other policies for controlling interactions with new technologies through the pluggable architecture. Each plugin will be controlled by pre- and post-process policy enforcement points. Are there other types of interaction categories that should be addressed? Is it sufficient to focus on policies for managing technology, users, and collections? One way to assess this is to consider the policies for trustworthiness and ask if there are other types of policies that need to be implemented. The major candidate for another type of interaction category is sustainability requirements for managing the archives. Two reasons that there are a relatively small number of default policies is that the data grid middleware implements a highly controlled environment and all data management operations are virtualized. The data grid is designed to implement controls on the collections independently of the controls implemented by each storage technology. In particular, all users are authenticated, access controls are applied on every data grid action, actions are automatically redirected to the correct storage location, when files are moved, their location is automatically updated, the rule queue is periodically checked for delayed rules, metadata is directly linked to each digital object through a unique object ID, actions are translated to the protocol required by each remote resource through a plugin. The data grid middleware maintains internal consistency across operations within the distributed environment, automatically updating the persistent state information independently of where the driving action takes place. The virtualization mechanisms provided by the data grid minimize the number of policies that are needed. Would additional virtualization mechanisms minimize the number of required policies? Multiple approaches are in production use to manage interoperability between different technologies. Approaches include brokers, services, and union catalogs. Brokering technology manages interoperability between access protocols. The protocol used by one technology is transformed into the protocol required by another technology. This works as long as both technologies support similar operations. Services provide a uniform interface for specific actions. Examples include REST services to get, put, and list objects. If each technology is required to support an interface based on the standard services, then all technologies can be accessed through the same mechanism. Union catalogs provide interoperability between schema, mapping the metadata used by each data management application to a common indexing system. A query can be issued to the Union Catalog to find which data management systems hold the desired data. A request is then made to the specified site for the data. A data grid integrates the interoperability mechanisms from broker services and catalogs to support interaction with multiple types of technology. The data grid could be replaced by a standard set of services that are managed by a broker which accesses a union catalog. The services would need to include all of the operations supported by the data grid, including replication, metadata loading, access control setting, distribution, retention, disposition, and auditing. So far, the set of services provided by data grids cover a much wider range of operations than provided by brokers. Take 7 minutes and complete exercise 111. Identify your collaboration requirements for quotas, strict access controls, integrity. Are there other requirements that are needed for a research collaboration? Please load a paragraph describing your result into the lifetime library in the subcollection class INLS 624 by the end of today's class.